Every molecule has a name. Some of them can be very, very complex. Some of them can occupy pages for these systematic techniques. Let's not go there, but let's name a few binary molecules and see the system that is going to develop. I think you're going to find that it's a little bit like language. Things develop, they evolve in a certain way, and it's by no means the best way, but it's the way we got. So let's do it by example. You've seen that molecule before. What is it? I'm sure most of you are thinking water, but we can name it systematically, and maybe you've heard that. Please pass the dihydrogen monoxide. We're learning something here. Two of these, one of those, di, mono, there you go. Maybe you know this one. This one can raise you from unconsciousness in the form of a gas. And maybe you know that it's ammonia, but try that systematic name, and you should come up with nitrogen trihydride. Notice we're not saying mononitrogen trihydride. We dropped the mono, right? Otherwise known as ammonia. And always refer to what you already know when you're wondering whether to do something like that or not, right? We don't say monocarbon dioxide, we say carbon dioxide. Here, that's hydrazine, but we could say dinitrogen tetrahydride. So I think you're starting to see the system. You turn the oxygen to an oxide, you do the monos and the dis, but not in the beginning. And like I said, some of this is a little annoying, but work with what you already know and you will avoid making some of the mistakes. Let's name all these. Sodium chloride, right? No problem. This one, you should know it, right? Carbon monoxide. Beautiful. Now be careful here. It's one that's unfamiliar with you, and this is where an important rule is going to kick in. This is not aluminum trichloride. We just call it aluminum chloride. Rule is if it's ionic, mean a metal to a nonmetal, we do not use monodi-tri. Is that a good rule? By no means. Why not say aluminum trichloride? Everybody would know there's three chlorines. But you can come up with the fact that there's three chlorines just by applying the fact that aluminum's always plus 3, chloride is just about always minus 1, and you do it that way. I don't like it, but we're stuck with it. SO2. Do you like sulfur oxide? Do you like sulfur dioxide? I don't see a metal present, so I am going to use the monoditri. Now, another rule is going to kick in here because if you're dealing with iron or any of the transition metals, they are potentially polyvalent. They can be a bunch of charges, right? So this one is clearly plus 4 because each oxygen is minus 2. We're going to specify the charge because if you said at the dinner table, please pass the iron oxide, your mom might say, well, which one do you want? I got iron 2 oxide, I got iron 3 oxide. Oh, I want the iron 4 oxide. So you have to do that with the polyvalent region. It's a large region. It's the just about all of the D block, right? Most people avoid it for a couple of them, like say silver and zinc, but I think it's fair game to use it in any of those cases, just so there's no ambiguity. It does extend also into the lower parts of the P block as well as the F block. So there's no hard and fast rule about when to use it and when not to. So in my class, if you're wondering and its potential, yeah, I wouldn't use it for the group ones. I wouldn't use it for the group twos, but I would use it when it seems necessary. Now here, should I say silicon 4 oxide? I don't think so. Silicon's not a metal, so I simply say silicon dioxide. Get it? Here's the flow chart if you need it. That's how we name those substances. This is naming binary molecules.